Hello, this is Group 5 Video Presentation. The project is Video Encoder. The minimum features that the team implemented are the following. The ability to encode up to 100 JPEG images into one encoded file in under 5 minutes. The ability to play back the images from the encoded file at least 10 images per second. The ability to provide a command line user interface for encoding and viewing. The extra features that the team implemented are the ability to utilize 3 other image formats, to allow users to adjust parameters on movie creation in order to change this space for quality, and also provide 3 interesting real-time video effects during playback, and also provide Android clients for viewer. This is the basic program flowchart. First, we have the original image, then we put it under a DCT, which is discrete cosine transform. This is achieved by a MATLAB program, fdct.m. Then we convert these images formats to JPEG formats, which is achieved by a main function .java. And then we convert this image to a video using an external library called JCodec. Then we further compress this MP4 video into a smaller size video using FFmpeg library. Then we can use this video and view it on an Android client.
So next I will briefly introduce the DCT algorithm. It's a discrete cosine transformation. First we have the source image data and to transfer it to the RGB matrix and to do the DCT operation and do the quantization during it. So for the source image data, we just extract 8 by 8 blocks for the RGB data and do the DCT, and then do the zigzag to compute its coefficiency, and do the quantizer to ignore the high frequency part. Then we have the entropy encoder, then to get the compressed image data. After we get the compressed image data, then we do the inverse process for the DCT. It's inverse DCT algorithm, and do the dequantization, and then we get the 8 by 8 compressed image. Then we combine all the 8 by 8 blocks together, to reconstruct the image data. Then finally we get the compressed image.
There are 3 libraries that are used in this program. One is JCodec, and the other one is FFmpeg, and the last one is the video effect. The JCodec is basically a library that implemented a set of popular video and audio codes. And in our program, the JCodec basically allows the program to encode a sequence of image to a MP4 format video. For FFmpeg, the purpose of this project to use this library is to further compress the video. And the last library is the video effects library, which is the open source library on GitHub, which we can use it to do the real-time effects on Android clients.
So I have, the input can be multiple image formats. It includes the TIFF, GIF, and JPEG 2000. And we can convert, the input can be, the DCT algorithm can compute these different image formats, and Java will convert all the image to the JPEG for the generation of the final video. And to fulfill this requirement, the program utilizes a buffer image data structure which accepts the image formats and rewrites them in the processing folder. So for quality adjustment, it's about during the process of DCT, the user can change the parameter Q to adjust the quality. The Q refers to the scalar of the quantization matrix. So if we scale up the Q, then we can ignore more higher frequency pixels and set them to 0 after the DCT process. Thus, we can the alternative of Q will have the impact on compressed file size and image quality. So the real-time factor including the red scale transformation, invert color, and brightness adjustment. The principle of these 3 effects is the first red scale transformation is a feature implemented by Video Effect Library. The principle is to scale up the pixel values in the red matrix from the RGB imported by the images. The invert color is just adjust the value of the high value for pixels to low value and low value pixels to high value. So it's implied by the by change the value with the opposite value of the original value minus by 255. The brightness adjustment is transfer the RGB matrix to the YCRCB matrix to adjust the brightness of video. Just scale up the value of my Y matrix to make the video more brighter. Yeah. For the Android client, the Android client designed by using the Android Studio. In order to make the Android client works, we need to add the target MP4 file into the set folder and then modify the file name under the main activity Java to the name of target file. And then we apply Android emulator to run the APK instead of using the real hardware, since none of us have the real Android device. So now it's a time for our demo. First, we show the 100 original images of the beach. The image has a quality 1080p, and you can see that the quality is pretty good. We're gonna to use a DCT algorithm implemented by MATLAB to compress these images to a zip file, and then use our Java code to generate a new video as a MP4 format for our Android client. Now we are opening the MATLAB and running the DCT algorithm. The number shows here means that how many images have been scanned. After the MATLAB, after implementing the DCT algorithm, we use our Java code to generate the final videos and do further compress. You can see this is the main structure of our Java code. And we're going to use a command line interface to generate the video. That's for our Android client. We use a J-code library as a JPEG decoder and outputs of a video of the format of MP4 for the compatibility of our Android client, and we use a FPG library to further compress our final videos. Now I'm gonna show the final video. So there's a two stage for our compression and generation of the final video. First is the G codec. So we generate this DMP.MP4 video. You can see that the quality of the video is not that good because it says because that we want to save the most space with least best quality. And then you can see this is the output video. This is our final videos output to our Android client.
So for the Android client, first what you need to do is launch the Android Studio. And then download the effect folder and open the effect project. Go to main activity.java. Rebuild the project. Then you need to copy the video you want to play to the access folder. activity.java. Change the file name to be the video name you want to play. And then click Run button. So actually here we are using an Android emulator because none of us have an Android device. The emulator we are using right now is Pixel 2. So after you launch the emulator, what you need to do right now is wait for the apps to run. And on the interface of the apps, there are actually 4 buttons. One is red, another one is invert color, and the other one is brightness. So if you click on red button, it will change the color to be red. And if you click the invert color button, you will invert the color of the video. And then the brightness button will increase the brightness of the video.